Welcome. In this video, we will explain the autoflight system of the Airbus A320.
The autoflight system helps the flight crew control the aircraft's flight path, speed, and navigation, while reducing workload and improving safety.
You're cruising at 35,000 feet, looking out the window, and it all seems so smooth, so effortless. Have you ever wondered who is actually flying this thing? Well, on a modern airliner like the Airbus A320, a huge part of the answer is a mind-blowingly complex system of computers. So today, we're going to pull back the curtain on the magic of automated flight to see exactly how it all works. I mean, just look at this thing. It's an incredible piece of engineering. But the real secret isn't just in the wings or the engines, it's in the brain. So the big question is, how does this massive machine take what its pilots want and then safely and efficiently fly a pre-planned route across entire continents, pretty much all on its own? Well, that's exactly what we're about to break down.
So here's our flight plan for today. First, we'll get the big picture of the system that flies the plane. Then we'll meet the two key types of computers making it happen, who we'll call the planners and the guardians. After that, we'll look at how the pilots actually talk to this digital crew before bringing it all together to see the automated cockpit in action. Ready? Let's go.
Okay, so let's start with the core concept, the plane that flies itself. The best way to think about this is like the aircraft's central nervous system. It's the whole network that connects the pilot's intentions to the physical controls of the plane.
And the official name for this system is the Autoflight System, or AFS for short. Its job sounds simple, but in reality, it's incredibly complex. It has to take a flight plan, figure out exactly where the plane is at any given second, and then calculate the perfect commands to control the engines and all the moving parts on the wings to follow that plan.
Now, what's really cool about this slide is how it breaks down that process. See, over on the left, you've got all these sensors, things like navigation radios and inertial systems, constantly feeding the AFS information. The AFS then crunches all those numbers and sends out orders to two key places, the flight controls, which move the surfaces on the wings and tail, and the FADIC, that stands for Full Authority Digital Engine Control, which is basically a dedicated brain for each engine.
But here's the thing. This isn't just one computer doing all that work. I mean, that wouldn't be nearly safe enough, right? Of course not. So the crucial point is this. To get the kind of reliability you need for a commercial airliner, the whole system is built with redundancy. It's not one brain, it's four, all working together. And these four brains are actually two distinct pairs. We've got two flight management and guidance computers, which we're going to call the planners, and two flight augmentation computers, who we'll call the guardians. Each pair has a super specific and vital role in the journey. So let's meet them.
First up, let's meet the planners. The Flight Management and Guidance Computer, or FMGC, is really the strategic mind of the whole operation. It's responsible for the entire flight, from the moment you leave the gate to the moment you arrive.
You know, each FMGC kind of has a dual personality. The first part, flight management, is the long-term thicker. It's the what and the where. It handles the entire flight plan, keeps track of the plane's position, and is always calculating the most efficient way to fly. Then, the second part, flight guidance, takes over. That's the how. It's responsible for the hands-on execution, telling the autopilot, the flight director, and the autothrust systems exactly what to do to fly the path that the management side came up with.
And this diagram just illustrates it perfectly. You can see how the FMGC is the central hub. Pilots put the long-term plan in using those keyboard-like devices, the MCDUs. But for immediate changes, like right now, they use the knobs and buttons on that panel up top, the FCU. The FMGC takes all of that, processes it, and then sends commands out to the plane while showing the pilots exactly what's going on their main screens.
Okay, so if the FMGCs are the planners, who are the guardians? Well, while the FMGC is busy planning and guiding the flight augmentation computer, or FAC, is the silent protector. It's constantly working in the background to make sure the flight is safe and stable.
The FAC's main job is something called flight augmentation, which is really just a fancy way of saying it makes the plane easier and safer to fly. But as you can see right here, its most critical role is managing the flight envelope protection. This is the plane's ultimate safety net.
So how does the safety net actually work? Well, a few ways. First, the FAC smooths out the ride by damping yaw. You know, that little side-to-side fishtailing motion, which makes for a much more stable and coordinated turn. Second, it sets hard physical limits, automatically restricting how far the rudder can move at high speeds to prevent dangerous stress on the airframe. And third, it actively creates safety buffers, managing that flight envelope, which is the key to stopping the plane from ever getting into an unsafe situation.
So what is this flight envelope protection? Well, it means the FAC is always watching. It's constantly on the lookout for dangerous conditions, like if the wings are angled up too high and could stall, or if there's sudden wind shear. It's also monitoring the plane's energy. If it gets too slow and is at risk of not being able to climb, the FAC commands the warning computers to give the pilots a very loud, very direct, and very clear message: speed, speed, speed.
Okay, so we've met our digital crew, the planners and the guardians. Now, how do the human pilots actually talk to them? How do they give commands and manage this incredibly sophisticated system?
Well, they communicate through two main interfaces. Over on the left, you've got the Multi-Purpose Control and Display Unit, or MCDU, and on the right is the Flight Control Unit, or FCU. Now, they might look a little similar, but they do two very, very different jobs.
Here is the absolute best way to think about it. The MCDU is the strategist's tool. This is where pilots do their long-term planning before the flight even starts, programming all the waypoints, altitudes, and speeds for the whole route. The FCU, on the other hand, is the tactician's tool. It's for immediate, in-the-moment commands. Want to turn on the autopilot? Need to change your heading to avoid some weather? Climb to a new altitude right now? That all happens on the FCU. It's strategy versus tactics.
So, we have the planners, the guardians, and the interfaces the pilots use to talk to them. So now, let's put it all together and see this amazing digital orchestra in action.
Okay, this is the whole shebang. You can see the entire flow. The sensors on the left provide all the raw data. That data flows into the automatic flight system, where our planners and guardians, the FMGCs and FACs, do all their complex calculations. Then, based on the flight plan and what the pilot wants, the AFS sends those precise orders out to the flight controls and the engines, and the plane just does it.
So while all of this is happening, what are the pilots doing? Just sitting there? Absolutely not. Their role is critical. They are monitoring, they are supervising. Using these big screens right in front of them, they are constantly watching the AFS, making sure it's following the plan, managing the systems, and they're always ready to step in at a moment's notice.
And that brings us to what is, without a doubt, the most important point of all. Despite all this incredible automation, the human pilot is always in command. Period. The system is designed to give ultimate authority to the crew. If a pilot just puts a little bit of force on their side stick or presses that big red takeover button on top, the autopilot instantly disconnects. The human is back in full control.
When you step back and look at it, the A320's autoflight system is this incredible symphony of planning, guidance, and protection. But it also shows us this fascinating partnership between human and machine. And that leaves us with a final, thought-provoking question. As these automated systems get even smarter, even more advanced, how will the fundamental role of the human pilot continue to change right along with them?
If you enjoyed this video and found it useful, please press the subscribe button on. Thank you for watching, and see you in the next video.